After Pro.
Hi guys, for this video we will talk about the combination of series parallel and parallel series circuits. In solving this kind of circuit we have to consider the series sections and parallel sections of the circuit as an independent unit. And using the rules given in my last videos which we are going to apply for each of one. And now we go to examples to explain the procedures. Here are the given. E is equal to 48 volts. R1 is equal to 6 ohms. R2 is equal to 12 ohms. R3 is equal to 3 ohms. R4 is equal to 15 ohms. R5 is equal to 90 ohms. R6 is equal to 30 ohms. Calculate for A. Total equivalent resistance R sub T. B. The total current I sub T. C. The voltage drop across each section. D. The current through each resistor. E. The total power taken by the entire circuit. So the solution guys will be R total is equal to R1 times R2 divided by R1 plus R2 plus R3 plus 1 all over 1 over R4 plus 1 over R5 plus 1 over R6 since it is a combination circuit. First you have to solve equivalent circuit of R1 and R2. Then, you also have to compute the equivalent circuit of R4. R5 and R6, after that the circuit will become a series circuit. So you just have to add the equivalent circuit of R1 and R2. Then R3, and plus the equivalent circuit of R4, R5 and R6. So again R total will be, R sub T is equal to, R1 times R2 divided by R1 plus R2. Plus R3, plus, 1 all over, 1 over R4, plus 1 over R5. Plus 1 over R6, by substituting the values of the given. We have 6 times 12 divided by 6 plus 12, plus 3. Plus, 1 all over, 1 over 15, plus 1 over 90, plus 1 over 30. And the answer will be equal to 16 ohms. Then next is the I total. I sub T is equal to E divided by R sub T. Substituting the values will be equal to 48 divided by 16, and the answer is 3 amperes. So the current flowing to the circuit will be 3 amperes. For number 3, find the voltage drop across each section. Since we know already the equivalent resistance of R1 and R2, which is equal to 4 ohms, so E sub X denoting the voltage drop across R1 and R2, which is equal to I sub T times the equivalent resistance of R1 and R2. Substituting the solved values, we have 4 times 3, which will result to 12 volts. So voltage across R1 and R2 is 12 volts, and for the voltage drop across R3, E sub 3 is equal to I sub T times R3, so E sub 3 is equal to 3 times 3. Then the answer will be 9 volts. Lastly for the voltage drop across R4, R5 and R6, which have the equivalent resistance of 9 ohms, so the solution of E sub Y which denote the voltage drop across R4, R5 and R6. E sub Y is equal to I sub T times the equivalent resistance of R4, R5 and R6, which is equal to 3 times 9, that will result to 27 volts. Next will be the current through each resistors. For R3 the current is equal to I sub T. Since it is connected in series with the source, the current flowing in R1 will be I1 is equal to E sub X divided by R1, so I1 is equal to 12 divided by 6, which will result into 2 amperes. For current flowing in R2, simply I2 is equal to E sub X divided by R2, so I2 is equal to 12 divided by 12, which is equal to 1 ampere. We go now for I4 since I already solved I3. I4 is equal to E sub Y divided by R4, then that will be equal to I4 is equal to 27 divided by 15. That will result to 1.8 amperes. For I5 which is equal to E sub Y divided by R5. So 27 divided by 90 that will result to 0.3 amperes. So lastly for I6 which is equal to E sub Y divided by R6. Then the solution is 27 divided by 30, which is equal to 0.9 amperes. As you can see the current total is equal to the sum of I1 and I2. And also I total is equal to I4 plus I5 plus I6, which will be explained to you in my next videos. For the total power of the circuit, the solution will be P sub t is equal to I sub t squared times R. Or E sub t squared divided by R, and also I total times E total. I will going to use current and total equivalent resistance. So the solution guys is P sub t is equal to I sub t squared times R total, which is equal to 3 squared times 16, which result into 144 watts. It is up to you guys what formula to use in solving P sub t of that circuit, since the parameters are already given. Next example guys is a parallel series circuit. As you can see, it is a parallel circuit, but inside the branches of the circuit it have a series connected resistors. Again, we have same value for the voltage sources and resistors just like the first example. E is equal to 48 volts. R1 is equal to 6 ohms. R2 is equal to 12 ohms. R3 is equal to 3 ohms. R4 is equal to 15 ohms. R5 is equal to 90 ohms. R6 is equal to 30 ohms. We also have the same questions like number 1 example. Calculate for a total equivalent resistance R sub T. B. The total current I sub T. C. The voltage drop across each section. D. The current through each resistor. E. The total power taken by the entire circuit. So the solution guys will be AR total is equal to 1 over R1 plus R2, plus 1 over R3, plus 1 over R4 plus R5 plus R6. So it is equal to 1 over 6 plus 12, plus 1 over 3, plus 1 over 15 plus 90 plus 30. Then it will become R total is equal to 1 over 18, plus 1 over 3, plus 1 over 135. So the answer is, R total is equal to 2.52 ohms. As I already discussed in solving parallel resistor, the equivalent resistance will less than the smallest unit. If you still did not familiar with that, you may check my other videos for you to understand this topic. Then for letter B question, which is the total current, the solution will be, I total is equal to E total divided by R total. So I total is equal to 48 volts divided by 2.52 ohms, which will result into 19 amperes. Then for the letter C question, which is the current through each resistor, since R1 and R2 is in series connection. Their current is equal, so IR1 is equal to IR2, which is equal to E divided by R1 plus R2. Substituting the given, then it will be 48 volts divided by summation of 6 ohms plus 12 ohms. The current flowing at IR1 and IR2 is equal to 2.67 amperes. And for resistor 3, the current IR3 is simply E divided by R3, which is equal to 48 volts divided by 3 ohms, which result to 16 amperes. So IR3 is equal to 16 amperes. And for the current of R4, R5 and R6, the solution is IR4 is equal to IR5 and also equal to IR6. Since they are connected in series, the solution is E divided by the summation of R4 plus R5 plus R6. So 48 volts divided by 15 ohms plus 90 ohms plus 30 ohms. That will result to 0.36 ampere. So as summary guys, IR1 and IR2 is equal to 2.67 amperes. Then, IR3 is equal to 16 amperes. And lastly, IR4 and IR5 and IR6 are all equal to 0.36 amperes. And to confirm if your answer is correct, simply add the 3 currents and compare it to the answer for total current. So 2.67 amperes plus 16 amperes plus 0.36 amperes, that is approximately equal to 19 amperes, which is the same to the computed total current. And lastly guys is the total power taken by the circuit. So simply P total is equal to E total times I total. E total is equal to 48 volts, and I total is equal to 19 amperes. So P total is simply 48 volts times 19 amperes, which will result to 912 watts. You can also try to compute for the power taken by each resistor, by simply using I squared times R, since I already computed for their respective current.
Hey guys, Thank you for watching. See you on my next vlog. Please don't forget to like, share, and subscribe for more videos.